Yeah, positive. You're not able to see what is there on my screen, right? That is cheating. Okay, so we'll start set. Right? The second part of the so yes, what is that? What collection of elements, objects, numbers, sunshines. So, give me one example of set in this. Give me an example of finance. See, you guys, this chair, table, screen, all together on formula. Yeah, if my voice audible, you keep poking it. Okay. No. So set is a collection of numbers. So yesterday we saw intervals also. We saw how do we write in terms of intervals, right? Can you guys write for interval? I'll give you one problem. Shall we write? So we'll learn the properties of sets today. But before that, can you write in set builder form the real numbers? Okay, so write this A, B. How you will write this in set builder form? Do you know? Okay. A and B are real numbers. Okay, so how you will write in set builder form? Good. Where's the paste option? That's the next. Of using a digital whiteboard or whatever board you want to say. I hate it. I hate this. Anyway, yeah, do it. Write this. I'm giving you an interval. Okay, this is the interval. That's how we learned yesterday how to write interval, right? This is a closed interval. That means we are including A as well as B. Okay, why you guys are so sad? What happened? Torches in your school? Then no food today? No breakfast? Okay. Huh? Then why you guys are not shouting? Solve it. Write the answer. I mean. How do you write this set in set builder form? This is also a set, no? Let's say if I'm saying this as set S. So how do you write this in set builder form? Anyone? Do you know what is this symbol? See, I was, as of now, I was assuming that you guys know this. This is epsilon, right? You're a Cartesian. Right? So epsilon means belongs to, yeah, correct. So epsilon, okay. So when you are saying, when we write this symbol, what does this mean? If I'm writing A belongs to R. What is this R? R is a real number, set of real numbers. So real numbers can be any number that you can write on the board. All are real numbers. Okay. Imaginary number, have you studied that? No, not yet, right? You don't know. Okay, fine. So A is a set of real numbers. That means A belongs to R. Similarly, B also belongs to R. That's what I'm giving you. That's what the information I'm giving. Now, write this. You have to write in terms of real. not x. X is equal to, then you have to define a and b as well, right? Because I have defined here a and b, isn't it? So write a and b. So how you will write this set? Anyone? Just keep telling me. How do we write in set builder form? Right? This inside curly braces we write. So x such that x belongs to x is equal to, right, a comma b, or you can write x belongs to all real numbers. Okay, like this also you can write, and then you can define a, like I told you, set builder form. You can also write like one statement I will write like this. Okay, x. Okay, this is also correct. Now again, how can you write this? X, you can directly write like this. A belongs to R, B belongs to R, and you can write the statement X. That is sorry, this, because X belongs to A to B, no? So we can write X is greater than equal to A, lesser than equal to. This is also correct. Okay. So in different manner you can write very unique. This set builders. And if in your school they are asking, you are not supposed to write this, ask them like why you are not, because they don't have any. The thing is, you can write in any form, but the most easiest form we try to write always like that. Okay, whatever the easiest form is. So set builder form, we try to like that. Okay, now I'll give you one more problem. Let's do one more. Okay. See, in right now we are studying only about intervals. So this is interval. Yesterday we learned about some of the intervals, all types of brackets. We saw all types of, right? So if I'm writing this a comma infinity, what does this mean? I'm saying all a belongs to real numbers. Yeah, that means whatever is the value. Okay, I can also write x is equal to, I can write like this also. X is equal to from a to infinity. That means x can be any number between a and infinity, but it cannot be a, it cannot be infinity. Okay. And one more thing, one important thing about this interval, that whenever you are using infinity, that means you will always use this bracket. Why? Because infinity is not a real number. You cannot write it. What is infinity? That is not defined. Okay, so something which is not defined, you cannot include it in the interval. Okay, that's why whenever you are writing infinity or minus infinity, you will always use open bracket. This is called open bracket. Okay. Okay, let's draw the number line for this. So number line, how you will draw? This is your plus infinity. This is your minus negative infinity side. So this is always, you will always draw like this. All numbers. There is no need of drawing this, but still, let's solve a quadratic equation. Now you will be like, okay, why we are solving quadratic equation? We are just learning intervals, how to write intervals. Okay, one by one, we'll see. After this, we'll see Venn diagrams. All right. Okay. So x square plus 2x minus 2 is equal to 0. Can you solve this? This is just some random quadratic equation. Hopefully, everyone knows how to solve a quadratic equation. What do you mean by quadratic equation? It's a polynomial of second order polynomial, right? You know what a polynomial is? That you can write in terms of a x to the power of m plus b x to the power of n minus 1. Okay, so that's how we write a polynomial. You don't, this is, see, this part is called expression, and complete this part is called equation. Equation has a not zero, not necessarily zero. It has to have an equality sign. Then we say it's an equation, and this part is an expression. Fine. I'm just giving you a different way. They will not ask you. Solve this and write in intervals. Write in the form of intervals. Tell me two values of x. Done. How do you solve the quadratic equation? I think in 8th standard you have studied that, right? Then again in 10th standard you must have studied. Okay. How do you solve the quadratic equation? Okay, that is one method, but that method will not work. Yeah, you can use any formula you want, but you should not take this long to solve a quadratic equation. Some loci is there in your text. Write in this form. Write in this form. The interval form. Write the answer. I'll write. What? Not set builder form. Interval. Interval that this form. This form. This is interval, no? Then after we can write in set builder form. Solve this quadratic equation. Dude, solve the quadratic equation. How much you got? You guys know how to solve it. How much you got? Yeah. Quadratic equation distance. Okay, no issues. That means there is some problem in your. Okay, so we use this formula, right? X is equal to minus b plus minus square root of what? B square minus 4ac. Where from you got this formula? How do you get this formula? Right? Good. So just solve it. B is what? What is B here? Dude, B is 2. A is equal to 1, B is equal to 2, and C is what? Minus 2, right? Now just put this value here. So minus 2 plus or minus 4 minus minus 2. 1, so 2. How much? 4 plus 12 plus 8. That will be 12 upon 2. Okay, so minus 2 plus minus root 12 is how much? How you can write root 12? 2 root 3. Yeah, it is 2 root 3. 2 root 3 upon 2. So can you write this? Minus 1 plus minus root 3. Can you write this? Huh? I'm just divide. Dude, don't ask me that I have to solve this. I'm dividing it by 2. You're getting it or not? Yes. Our main aim is to learn that how to write in terms of interval, not to solve quadratic equation. So two values of x we are getting. One is minus 1 plus root 3, and this is x1, and x2 what we are getting minus 1 minus root 3. Which one is bigger, x1 or x2? X1 is bigger. You, Gosal? Huh? Sunshine? X1. Okay, so since everyone agrees, x1 is greater than x2. Because obviously, minus 1 is right. This is adding root 3 is how much? 1.7. So that means it is somewhat 0.73. And this is what? Minus 0.73 something. Okay, not minus 2.7. Just agree with me. Don't do that. So approximately this is 0.73 and this is minus 2.73. Fine. Now let's represent this on number line. See here. Why I'm teaching you this thing, you will thank me for this later. Not later. Okay. So we have three numbers. One is 0. Okay. 0 is not required at all. Okay. So we can just delete 0. Not required. So let's complete. This is minus 2.73 and here it is 0.73. Fine. These two values we are getting. So in terms of interval, if I'm saying, you can just write your answer x is equal to like this, minus 2.73, 0.73. That means that this the meaning of this statement is that x is equal to this value and x is equal to this value. No value other than this. Yesterday I think I mentioned that inside curly bracket, that is literally all only these values. That's why we are writing set also in curly braces. Okay. Now if suppose if instead of giving this, I'm giving you this sign, greater than or equal. Inequalities also you have solved. You have solved inequalities, right? How come you are saying this? You have not solved inequalities. Okay. Anyway, if inequality, if you are solving, that means okay. If you, even if you don't know, there is no point of talking. Okay. Let's delete it. Why didn't you solve inequalities? I mean, ICSE board 10 standard they have inequalities. CBSE you don't have inequalities. Why? But you know you also not study by yourself. It will be definitely exact. Let's say that don't take COVID into action. Everything why this happened? Because of COVID. Why you slept? Because of COVID. Why you got married? Because of COVID. And why you don't have a girlfriend? Because of COVID. Yeah, that's what you are saying, no? Okay. Anyway, if you haven't studied it, anyway, suppose let's give you another problem. X I'm saying is greater than 0.73 and x is lesser than minus 2.73. That's what the value we got. Okay, if in inequality we have got this value. How do you write it in terms of intervals? In terms of intervals. Write in terms of interval this one. Write this in terms of intervals. You can do that, right? Now I'm giving you first draw the number line. You know how to draw the number line? That you have studied, no? Just mark these two on number line. This is x1, this is x2. So this is your x1, this is x2. I'm writing like this. Now what I'm saying, x1, listen. x1 is greater than 0.7, right? That means all the values this side. Fine. x1, these are the two values of x. These are the 2 points, x1 and x2. So x1 is greater. That means here x1 means x only. I'm just giving 2 points, x1 and x2. Okay, two numbers. So x is greater than 0.73. That means all the value greater than this, right? But we are not including x1. x1 is excluded, and x is lesser than minus 2.7. So all the values this side. Fine, but we are not taking minus 2.7. You're understanding or just simply keep on talking? You're understanding or not? Yes or no? So shall we write in terms of interval? How you will write? You'll just simply write minus 2.73 to 0.73. This is correct? Dude, this is not correct. You have not understood. You haven't understood anything. Just for this number I have given for this to write in terms of intervals. How do you write this? Here it is what? Minus infinity, here plus infinity. Now you have Now you have to take only these intervals, right? You have to take these intervals, write these intervals and this. So you will write x belongs to see minus infinity to which number? X2. X2 is how much? X2 minus 2.73. Fine. And X2 also we are not including union. Okay, union again it is coming. We will study what union is. And this is 0.73 to infinity. We are not including 0.7. This is x1 and this is x2. Fine. Anyone is having any doubt? See, x1 is greater than 0.7. That means x is greater than 0.73 and x is greater than this. So you are understanding or we have any doubt? We have to write only this. We are excluding this part. Okay, we are excluding this part. We are not. X value does not belong. It belongs only here or here. Okay. Can you write in terms of interval? Just write it down and we'll do one more problem. Do it fast. We have to finish this segment, but tomorrow we have to finish this chapter. So if wait, don't look at me. Don't look at me. Don't just copy, okay? Write by yourself. Can you write this in draw the number line for this and what? Yes, write in intervals. See, if you can draw the number line, it will be easier for you to write in intervals. Okay, you can open your mask and you can say no problem. Fold, you have fold, so you expect to. So that is the. Okay, I should not walk here and there. I'm hindering everything, is it? That's what you're saying. Some story is going on. Tell me. I'll also enjoy. Yeah, you can use any type of practice. Yeah, use it. How many of you are done? You don't have any explanation. Currently bracket means what? Currently bracket means only that number. Yeah. When I'm saying any number is greater, if x is greater than 1, it can be 1.1, it can be 1.2, it can be any number. Right? So use your brain at least that much. Please don't act like a 2-year-old. Yes, x is greater than equal to minus 3, but x is less than. How do you draw it on number line? Any one of you have done it? Any of you? If I have to write 1.7, check your number. You are getting minus infinity to minus 2, right? In between that is minus 10, right? I'm saying x is greater than equal to minus 2. So is okay. One, yeah, anyone? Okay, let's see here. See here, all of you. First of all, draw the number line. It's very easy. I think you know how to draw this. Then mark the number. Which one is the greater number? Root 3. And lesser one is minus root 3. This side is plus infinity, this side is minus infinity. Even if you don't write, it doesn't matter. It's understood. Okay. Now, what the problem is, x is lesser than root 3. X is lesser than root 3. Fine. And x is greater than equal to minus root 3. Understood? You have to include minus root 3 here. So you will write x belongs to minus root 3. You are getting only these numbers, no? You are getting only these numbers minus root 3 to root 3. And which bracket we'll use? Close bracket where? Which end? This? This? What? What is the meaning of this bracket? Number will be included. What is the meaning of is root 3 include? Are we including root 3 open? Yes. One side it will be square bracket, and because we are including minus, right? You see here, we are taking x is equal to sign is there. Okay, look here. X equal to sign is there in minus infinity. X lesser than. Okay. See, first get the basic concepts clear. Then only we can move ahead forward. It doesn't matter if we can solve all the calculus and we don't know. So don't worry, if your fundamental is good, you can solve all the problems easily. So that's what I'm trying to build it now. Okay. So here what bracket we'll use? We'll use this bracket. All right. Got it. Sunshine. Shall we do one more problem? This time I hope you can do it. Hopefully. Kushal Babu. Okay. So x is greater than equal to 5 and x is lesser than equal to minus 5. Do it. You don't have to write x1, x2 and all. And I thought you guys have understood it. Okay, it was my mistake that I did. First you solve it, don't defect it. Solve this first, then you can defect. Yeah. Draw the number line first. Draw the number line. X is greater than equal to 5. 5 is in the positive side of the number. X is lesser than equal to negative 5. Right? You don't have to write 3.14159. You don't have to write. Okay. Pi, by the way, pi is what type of number? Irrational. What? Those are all irrational. Okay. That means after decimal digit, when you divide it, it will not repeat. Not anything. Yeah. No, I don't. I'm not seeing it. Let's draw the number line, shall we? This part is very easy. Hopefully, marking is also very easy. Pi is greater, right? This must everyone must. Now what you have to see that x is greater than pi. So greater than pi means what? Right side, no? Huh? Lesser than minus pi means what? Left side. Lesser than means lesser means left side, greater means right side. Okay. So these numbers we are including. Huh? And both have equality sign. So both will be closed bracket. What? Yes or no? Now how do we write it? X, first write this interval. First write this interval. This interval first we are writing. X belongs to minus infinity to minus pi. Minus pi, what type of bracket will be here? In minus infinity, what type of brackets? Minus infinity. Anything. In minus infinity and plus infinity, always open bracket. Always. So this is open bracket. Okay, we are not. Now here there is a equality sign in pi. So this will be closed bracket. Union. Just write union for now. We will study what means. Pi to infinity. Again, pi, we are including, so close bracket. Correct? Only one girl has done it properly. Hopefully. You have not cheated. Yours is correct? Yours was correct, everything? So what you were writing when I was writing? Belongs to. See, this simply means this the value of x belongs to this interval and this. We'll study the meaning of union. Okay, we'll see the Venn diagram. Shall we do one more problem? One last problem. At least, please, everyone. Okay. What is he? It's a dummy number, right? He is usually 0.7. But E can be anything. You can write A, B, C, D, it doesn't matter. Just write. Draw the number line. First, always draw the number. Write the positive one, write the negative one. Then you proceed. Then see the statement. One. Just use the logic. Mathematics is all about logic. Why we study mathematics? It's a meaning of philosophy. Even though you are not going to use mathematics, but definitely. See? Anyone? One mistake, what you're doing. Instead of E, you can be A, B, C, See the quadratic sign. Where which are this is right. Okay, done. Everyone done? So that's how we do it. Now I am not giving you any problem. I will just write the answer here. So first we draw the number line. You write E negative V. And what is it? E now X is greater than E, right? So this side. Greater than means this side. And it is open bracket, right? You can see this is open, right? And here this side, X is lesser than equal to E. So it's a closed bracket. So we'll write X belongs to minus infinity to minus E, this bracket, close bracket, union, what? Fine. Everyone has got this thing? Okay, now we'll move ahead. Ah, well, give me some water here. It took 4 problems for you guys to understand. Even I am not sure you have understood. Have you? Yes? You can solve any problem like this now. This is just writing interval. This is not even a problem. And you take 10 minutes to solve a quadratic equation. Shame on you. Okay, no shame. Don't worry. Okay. Those of you who want to have water, you can have it. So yesterday we learned about sets, right? Set is collection of numbers or elements, right? Now we'll see different types of. Yesterday we also saw infinite sets and finite sets, right? What are infinite sets? Yeah, it is not like numbers, right? Numbers are all the real numbers. It's an infinite set. You cannot write all that in this person. Okay, so that is the example of like number of leaves. That is also infinite. Even though if you keep counting for 100 years, but I suppose you don't do that. So that means all the trees on it. That is also infinite. That is all the not all the data that is positive natural number. Because obviously number of leaves will start from 1. Right? So all natural numbers, all integers, all whole numbers, everything is a infinite. Okay, infinite set. Now, finite set like a number which is I'm saying x is greater than 2 but lesser than -2. So it's a finite set, right? We can count the numbers. If I'm saying natural number, so means minus what you can write -1, 0, and 1. These will be your integers in between. Obviously, x I have to write here. I have to mention. Without writing this is incomplete. X belongs to integer. And it is very necessary because if it is a real number, then again it is an infinite set, right? If I'm saying x belongs to R, if x belongs to R, then again it is an infinite set because real number is -1.11112. You can write a lot, infinite number of numbers. Okay, so that is a finite set. So understood what is the meaning of finite. Now what is equal set? Equal set. Yes. Like suppose this is 11th standard class. So how many students are there? Huh? 8. Suppose 18 12th standard also. Suppose there are 8 students. So only number of students are equal here as well as there. So we can say these two are equal sets, not exactly. Why? Because let's say there is a set A, E, I, O, U. Okay, of what are these? Elements. Okay, and I'm giving you a set B. Let's say A, B, C, D, E. See, for equals for A to be equal. So A for equal sets, if I'm saying set A equal to set B, where they are not equal, obviously, then all the elements of A must be in elements of B, and all the elements of B must be in set of A set A. Okay, so we write A must be subset of B, and B must be subset of A. Now, what is subset? Okay, I know. Subset, let's use the Venn diagram for this. Okay. Or subset, like okay, I'm giving you one more set. C is equal to A E. I'm giving you a set C. Vishal Babu, right? Yeah. So C in C, what are the sets? A and B. Now you see A and B is there. A. So C is a subset of B as well as A. You are getting the meaning of subset? You understand? You understand? Yes. All the elements of C is present in A as well as in B. So C is a subset of A. So you can write C is a subset. Oh, sorry, not this. Subset we write like this. Okay, subset of A, and C is a subset of B. Okay, it looks like C, but it's not. We write it like this. Okay, so just excuse me for that. You will understand this. So that's what the subset. That means all the elements of C must be present in all the elements of A and B. Then only you will say it's a subset. Like okay, in terms of Venn diagram. First, let's understand what the universal set is. Equal set, you understood, no? All elements must be equal. Like if I'm saying set A has set A is such that I'm set builder form writing X where such that X is equal to or X, or I can write X belongs to all positive real numbers. Okay, no, not like this. Wait. Just give me a moment. Positive natural number. Natural number is always positive. It is not negative. Okay. One statement is this. X is that X belongs to natural number. And set B, X such that X belongs to positive integer. See, these two are different statements, right? But they are same. They are same, right? Because natural, what is natural number? 1, 2, 3, 4, 5, 6, so on. What is positive integer? 1, 2, 3, 4, 5. So statement is different, but they are actually equal. So A is a set of B, and B is a set of A. So here we say A is equal to B. Set, these are equal sets. Okay, understood this thing? Statement is different, but the set is same. Now subset. Now if I'm giving you a statement that says that Z is equal to anyway, somewhere in books you can also get as integer is represented by Z. It doesn't matter. It will be written. Okay, or that this is just for understanding. You can write anything you want. Now I'm giving Z. X is such that X belongs to real number. Okay, I'm giving you some. Let's not write Z. So let's use something else. Let's write X. Capital X. Now capital X is equal to this X here belongs to what? Real numbers, all real numbers. Now you can see this A and B. A is what? Here A is 1, 2, 3, so on, right? B is also what? 1, 2, 3, so on. Fine. All these numbers are there as well. So real number means what? All the numbers, whatever number you can write, they are all real numbers. Fine. Am I understandable or you are understanding? will say there from the point. Okay. So that means A is a subset of X and B is also a subset of X. Understood? That means all the elements of A belongs to X. All the elements of B belongs to X. Right? This you can understand. Right? R is all real numbers. And this positive integers are also real numbers. Natural number is also a real number. Fine? Sunshine, any problem? Any doubt? Anyone, any doubt? Yeah, I know you don't have doubt, but when I ask you to solve the problem, quadratic equation 10 minutes I'm taking to solve. Don't do that. Please don't do that. Okay, so you understood what the subset is in terms of Venn diagram. Venn diagram also you have to say. Let's see. This was equal sets. Now, what is a null set? There is something called null set. What is null set? That is empty set. Okay, empty set, and it is represented by 5. If now you see all the set, you write any set that has 5 because 5 is what? It's a null set, right? 5 belongs to what? Nothing. There is nothing. When there is an empty set, call it 5. So we don't even write like this. We just write 5. 5 PHI. Yeah, it's a Greek letter. So you write like this. Sorry. 5. Okay. So now if now see here. This 5 is a subset of A. 5 is the subset of A. 5 is the subset of B. 5 is the subset of X. Why? Because 5 is a null set. 5 is present everywhere. You are understanding this paradox. 5 does not exist. But it exists everywhere. Right? You are understanding this thing, right? So 5 will be there in all the sets. Okay? Got it? Any problem or any doubt? Yeah, you have some doubt? Yeah, null set. It is null. That is empty. That's why it's sensitive. Like if you have nothing in your body, if I'm asking if you have nothing in your body, you will say yes. You don't have anything in your body. So it's the same thing. Null set is nothing. It has no elements. And so that means all the set will have one 5. That means one subset is 5. So we use it, we will see why we use it. Just give me few more time to explain you why we use it. That's a good question. Why we use it? I don't know. I'm going to answer your topic. So just write it down. Also subset you can also denote like this. Okay, subset you can also write like this. This means just equal to subset because all the element of A has to be equal to all the elements of B. That's why we write equal to. That's it. Even if you just write this curvature, that is fine. Done. All done. Fine. Now what is next? Venn diagram. Let's start the Venn diagram. We'll see what an null set is. Now why do we use Venn diagram? What is a Venn diagram? Now any other action you want to circles overlap. This is what Venn diagram. Okay, see, all the definitions are kind of. The thing is, why we use Venn diagram is to get a logical picture of our problem. You understand? You can, like yesterday also, I gave you example that some people Some of you play with. So that you can represent in terms of diagram. That diagram is called a Venn diagram. I know it's a very rough, but just try to understand. Have a proper definition. And nobody is going to ask for it. The understanding should be good. Okay. So before in Venn diagram, before studying Venn diagram, first let's understand what's a universal set. Can you give me one? What is universal set, by the way? Yes, exactly. It includes all the subsets. Okay? It includes all the subsets. You're understanding my point? Like here, the biggest problem that this X includes all the subsets. Fine. That means this we can say is a universal set, and these are their subset. This is their A and B are subset of X. That's why X is a universal set. Or you can say all the stars in Milky Way galaxy. So Milky Way galaxy will be your universal set, and stars will be your some stars, some planets. So those will be your sets, subsets. Right? Okay. So that's how we write a universal set. And in Venn diagram, we all the set. That means this complete box is your can be represented by capital U. Okay, capital U will represent it. So this is universal set. You understood? I'm not going to write all the definitions. Otherwise, I have to write a book. We are not here to do that. No, you already have for that. Just for what is going on. Now it can have different subsets, right? There. This if I'm saying this is a universe. So this can be Milky Way galaxy. This can be some other galaxy. This can be some other galaxy. Right? Inside that, there will be number of stars. Inside that, there will be number of planets. So suppose this is our Milky Way galaxy. Suppose, let's see. And and suppose inside there are planets, there are sun, there are meteoroids, right? All the things are there inside. So this is again subset of this set. This is the subset of this universal set. You are understanding my point, right? You're getting it, like rivers, like mountains, rivers, plateaus, plains, all are subsets of a country. Let's say country or land, right? So and if you go dive deeper into that, in river you have rocks, you have sand, you have water, you have fishes, everything is there, right? So those are also the subset of that particular set. So you can dig a lot, but the general idea is a subset, universal set is the what? Combination of all subsets. Okay, so right now, universal set, no need to write, but universal set is a combination of all subsets. So you understood, no? I think this example was okay for your understanding. So this is our Milky Way galaxy. You go and shine there only, right? You don't shine there. You shine everywhere. You should. So this is our universal set. Now there are sometimes there are for set operations. We'll study some terms like union, intersection. What is it? Okay, so first one is union. Okay, union is number of all the elements. Why you are writing? First, understand. Union, like if you have two sets A and B, so all the elements of set A and set B, when we are not taking, we are excluding the common elements. Okay, it was hard to understand. Okay, let's write with example A, E, I, O, U. This is the best example, I suppose. And again A, B, C. Okay. Now, if I'm saying A union B, that means when A union B must have all the elements, but here A appears twice, right? So we don't have to write A twice. So it will be A, B, C, E, I, O. Okay. So just once you will write the overlapping terms or the same terms only once. That is A union. So this is all the elements of set A. plus all the elements of set B, excluding the writing the common terms on the ones, writing the common elements on the ones. All right. Understood? Is there any problem in understanding? I hope not. Now there is some other term, one more term, that is intersection. Now what is intersection? Yes, we will write only common terms of. Now if we write and it is represented by downward union. So A intersection B, and this is union is upward union. Okay. Now you will say universal set is also represented, so it doesn't matter. Who cares? You can write like that. So A intersection B, can anyone say what is A intersection B? A and B is given, A is given, B is given. What is A intersection B? A and any other set? Yes, 5. Okay. 5 is got it? First, let's understand some of the operations involved. Now see, these union, these sets in Venn diagram, these sets like universal set and other sets. These for how do we? Okay, just give me the order. Okay, there is a Cartesian product of sets. Okay, intersection you understood. See, individually right now we are understanding all the terms and we will use all the terms for operation. So these are union, intersection. These are all operators which we will use for operations. Whose operation? Kidneys, sunshine. Huh? So what is Cartesian product of two sets? Let's write Cartesian product. What is Cartesian product? Anyone? Or Cartesian coordinate system? Have you heard of it? What is it? Cartesian product. Cartesian plane you must have studied, no? XY plane, XYZ plane. Have you studied? What? So why you are doing this? Okay. So how? What is Cartesian product? Anyone? Anyone have any idea what is Cartesian product? So suppose you have two sets, set A and set B, like here in the above problem. So it has all vowels A, T, I, O, U, and B as A and B, right? That's what. Now Cartesian product we write like A cross B is equal to. Again we'll write in curly bracket. How you will write it? A, yes. Yes, combination of both the sets. Right? A set with combination of all the sets. So A. So this element you will multiply like this. Okay. And similarly AB, then again EA. Got it? Similarly, you can write all the numbers. And how many numbers it will have? How many sets it will have? This is also a set. Right? So Cartesian product. How you will write it? Like this only you will write. A is multiplied by A. First element will be element from A. From element. Okay, then what will be next? EB, right? What will be the next? IA, IB, then OA, OB, UA, and UB. All right. So these are the. I don't think it's there in the answer. I am not sure about this, but still you should know how to write a Cartesian product. I don't think any problem is there. Do you guys just write a Cartesian product? So set A has two numbers, 1, 2. Set B has number 3. Just write the Cartesian product. Got it? What is it? 1, yes, 1, 3 and 2, no, not multi. See, this this element how you write? First element will be from set A, second element will be from set B. That's how we do the cross partition product. Not sorry, cross. I said multiplication. I'm sorry for that. Multiplication, I mean the partition product. That's what I must practice. So multiplication is a wrong word to use. I'm really sorry. So first element from here, second element from the set. And when you are writing B cross A, when you are writing B cross A, then you write A, B, A, I, A, O, A, like that. Then B, A, B, okay. So that will be your B cross B. This is your A cross B. Opposite. Okay, got it? Now in Venn diagram, shall we move ahead? Yeah, you have any doubt? Okay. Sunshine is having a lot of fun. Can we take 5 more minutes, right? We started late, so we can take 5 minutes. Okay. All right. What we are supposed to study now? We are studying Venn diagram. Okay, so in Venn diagram, see there are mathematical see this union and intersection are the operators, and we'll use some set products. Okay, or we can say set operations. Set operations. Okay, so how we are going to perform set operations? Like we'll first use only 2 sets. Okay, 2 elements we will use. Like we have a universal set, we'll use the Venn diagram. We have a universal set, this U. You don't need to write U all the time. Okay, if you want, you can write it. It doesn't matter. So, like suppose this is all the elements of set A and all the elements of set B. Okay, now you have some common interval there. Okay, so this is the common interval. This is called the intersection. Okay, now this part is A intersection B. Okay, now if I write A union B, so what will be A union B? Yes, correct. Sorry. So this whole part is your A union. A union. What? Intersection is this common part. This hash part is there. This is the common part. So you can write the common element. That's what we have studied now when we saw the definition of intersection and right. Now there is some. You finish this. Now there is something called complement of a set. What is complement of a set? Suppose we have a universal set. Now you can understand the Venn diagram, right? And you have a set A, set of numbers of set something A. Like the universal set is your forest, and A is your elephant in the forest. Number of elephants in the forest. So what is complement of A? All the universal set excluding A. Okay, so this you can write universal set minus A. Okay, that means this shaded portion, this portion, everything but A. So this is called complement, and we a dash. Okay, this is the set. It's fine, understood. Now, what will be? There is a question. Suppose we have the set. This is A, B. Now, what will be A intersection B complement? Anyway, this is intersection A complement. What X? What is the intersection part? This part is This okay. So this is the intersection part, right? This is what A intersection B. Fine. And I'm saying A intersection B complement. That is everything other than this. Okay. Kushal Babu, understanding everything. So everything other than this. This also. Got it? Huh? So now there is a theorem, that is De Morgan's. What is that? De Morgan's theorem, right? What is it? De Morgan's theorem, right? I forgot his name, sorry. I haven't studied for like 5 years. De Morgan's theorem. So De Morgan's theorem, it's very simple. Okay, first shall we write? Before that, we shall see some more example of sets. Okay, can you tell me what is this? I'll draw. This is a universal set, right? So far, so good. A, B. Now, how you will write this shaded portion? What is this shaded portion? How you will write it? Huh? Complement of? So the complement of B, this should also include. No? A intersection B is this part. So can you write this as A union B minus okay, this is your homework. This is homework. Tomorrow I want to see. Okay, this is yeah. Anyway, write it as homework. Number 1, number 2. What is this? How do you write this? This is just B, yeah. This is just B. You don't have to think too much. What you see is correct. That's what the Venn diagram is called. Huh? It's B, as well, everything is B. So why you are getting so confused? Okay, so there are some set operations, and we'll see there are 3 formulas. Is it? See, now there is something called disjoint sets. Okay, disjoint sets. What is this? What is the meaning of disjoint? It's not linked at all. So you have a universal set, and you have 2 sets inside. Okay, so this is set A, this is set B. Fine, but they are not. There is no common thing in set A and set B, right? So like this is the forest universal set. Where these are tigers and these are elephants. The tigers are in a different have anything in common. Don't say there are legs and there are 4 legs and don't start that shit. So okay, these are animals. Got it? So these are disjoint sets. What is this? Disjoint set. So A union B is what? How do you write A union B for this? A plus B. Yes. All the sets of this and this. Fine. A union B is that only, right? And what is A intersection B? Yes, null set. Fine. You're getting some ideas about null. That is your homework, by the way. Why do we use null set? Why do we use null set? Good point. Why do we use null set? Okay. So I think we'll stop here, and Hopefully tomorrow we can finish this chapter. There's nothing much in this one. Okay, let's we have time. We always have time. Yes, that we question. Why are you not speaking? So let's start. From tomorrow onwards, I will be wearing mask. Okay. So thank you very much. Please solve the quadratic. Please know how to solve quadratic. That is very important. I mean, whatever you have studied now, like trigonometry also, the third chapter is trigonometry. That we are going to study in detail. Till now, you might have studied 0 to 90. That too, one is 0, 30, 45, 60, and 90, right? And now this time we will cover all the angles from 0 to 60. Okay. Okay, wow. All right. Okay, see you tomorrow. Tomorrow we have class, right? See, next week I won't be there. So, is it possible that Thursday you guys can come for class? Is it okay? Oh, you have 10 class. How many classes you have on Thursday? Only 10. 1.5 hours. Then we'll take 2 hours of time. If you want, then only you can. I'll ask Raghav. I will be there next week. Okay, so if you guys want, then we can. Otherwise, we will be back in seconds. I don't want that. Why you? Look to me. My friend is left. Thank you very much. So this is mostly the basics of sets we have covered. There are a few more points, few more basic points. I think that will be covered tomorrow, and we will see some logical operations. Okay? So just go and turn the pages of the chapter. At least do that. Solve some problem. Ask some doubts. Okay? If you are not asking doubts, that means you are not studying at all. It's as simple as that. Okay? So go study. Ask. Go get out. Bye bye. Thank you so much.